My name is Muhammad Azlan bin Ali, and today I will present my research proposal titled Modular Bazaar-Proximate Anaerobic Digestion with Real-Time Segregation and Demand Forecasting. This work is under the Faculty of Electrical Technology and Engineering at UTM, supervised by Professor Madya Dr. Muhammad Herman bin Jamaluddin, and co-supervised by Professor Madya IR Dr. Ahmad Anas bin Yusuf. My presentation will follow the structure: security summary, problem statements, research gaps, objectives, scopes, and questions, proposed modular bazaar-proximate anaerobic digestion system, methodology, expected outcomes, milestone, significant impact, and finally, conclusion. Executive summary. Ramadan Bazaar generate predictable seasonal waste surge with daily increase of 15 to 21% above baseline and a month level increase of approximately 75,000 tons. Current mitigation strategies rely mainly on awareness campaigns, which are insufficient, leading to continued landfill dependence. My proposed solution integrates modular and anaerobic digestion near the source, Internet of Things based segregation and real-time demand forecasting. The prototype will be developed within 6 months and evaluated during a 30-day Ramadan period in Malacca. The target outcomes include achieving more than 60% methane concentration, more than 50% waste diversion compared to baseline, and operational stability through at least 5% contamination and forecasting accuracy with mean absolute percentage error below than 35%. Problem statements. The current system fails at systemic level. Predictable surge enter a landfill-oriented chain, causing sustained methane and leakage impacts. Recovery capacity is limited and untimely. At the bazaar level, operation constraints include variable feed, time constraint handling, and inconsistent segregation, which leads to contamination. Furthermore, there is a lack of real-time monitoring, routing, and forecasting. So, in my literature review, the research gaps that I found is that existing pilot anaerobic digestion and composting systems are mismatched in capacity and location relative to bazaar peaks. Decentralized anaerobic digestion systems are vulnerable to feed variability and contamination without active control. There is a limited evidence that Internet of Things segregation can sustain low contamination and improve anaerobic digestion stability. Forecasting models are validated at stall of bazaar level and rarely linked to routine decisions. Finally, there is a need for empirical Ramadan specific evaluation compared to awareness-based baseline. So, my research has two main objectives. R1, design and prototype the modular bazaar-proximate anaerobic digestion system, integrating modular anaerobic digestion, node Internet of Things integration, and forecasting within 6 months, targeting throughput of 1 to 5 tons per day. This objective 2 is to evaluate its performance during a 30-day Ramadan period against baseline practice, focusing on methane quality, diversion rates, and model greenhouse gas reduction. The research scopes covers engineering design, instrumentation, segregation protocols, forecasting accuracy, and field deployment in Malacca. So the key question includes what design approach ensures stable modular bazaar-proximate anaerobic digestion operation under variable bazaar feed. And the next question is how much improvement in methane quality, diversion, and greenhouse gas mitigation can be achieved. The underlying hypothesis is that integration of these modules will improve feed quality and control, leading to higher stability and diversion rates. This conjecture flow integrates bazaar stall, Internet of Things-based segregation, surplus routing, and modular containerized anaerobic digestion. Outputs includes biogas and digested, supported by real-time monitoring and forecasting-led decisions. The key idea is to treat unavoidable organics near the source, reduce contamination, and stabilize digestion through active control. The methodology consists of two phases. Phase 1 is to design, fabrication, bench trial, and integration of Internet of Things and forecasting. For phase 2, a 30-day Ramadan field operation at a selected bazaar in Malacca benchmarked against awareness-based baseline practice. Phase 1 focus on design and development of the modular Bazaar-Proximate anaerobic digestion prototype. First, we will develop the process flow diagram and piping and instrumentation diagram to define the system architecture and interface. Next, digester sizing will be calculated using hydraulic retention time and organic loading rate to establish the operational envelope. Following this, fabrication and bench trial will be conducted to validate throughput and stability under control conditions. We will then integrate sensors and the dashboard, implementing alarms and logging for real-time monitoring. Finally, a forecasting baseline will be built and connected to the routing and loading workflow to enable predictive control. Phase 2 involves a 30-day field evaluation during Ramadan at a selected bazaar in Malacca. The prototype will operate continuously and daily feed mass and contamination events will be recorded to assess segregation performance. Biogas volume and quality, including methane and hydrogen sulfate concentrations, will be measured alongside system uptime and latency. Diversion rates will be computed against baseline practice, and greenhouse gas mitigation will be modeled. Additionally, forecasting accuracy will be evaluated using mean absolute percentage error and its impact on surplus ratio versus the digestion outcomes will be analyzed. In this section, I will outline the data collection and analysis strategy. The data to be collected includes daily feed mass, sensor readings such as pH, temperature, gas flow, and loading patterns, as well as gas quality parameters like methane and hydrogen sulfate. Operational logs will capture uptime, latency, and fault events, while forecasting inputs and surplus rescue outcomes will be recorded. For analysis, we will compute key performance indicators such as biogas yield, methane concentration, diversion rates, and greenhouse gas mitigation models. Statistically, comparisons will be made against baseline practice to quantify improvements. Forecasting performance will be evaluated using mean absolute percentage error and diagnostic checks, and we will link coordination and loading variability to system stability. Finally, the findings will inform scale-up recommendations for broader deployment. In terms of expected outcomes, this research aims to deliver a validated modular Bazaar-Proximate anaerobic digestion prototype, complete with engineering artifacts and integrated instrumentation. An operational dashboard will be developed alongside segregation standard operating procedure and a hazard and operability study safety checklist. Performance targets includes achieving more than 60% methane concentration, a biogas yield of 0.35 to 0.5 per kilogram of volatile solids, and more than 50% waste diversion compared to baseline practice. Enabler targets are equally critical, maintaining less than 50% contamination, achieving mean absolute percentage error, less than 35% for last hour forecasting, ensuring that more than 95% system uptime and dashboard latency of less than 5 seconds. Finally, the project will produce a documented bill of materials cost baseline, and a clear scale-up pathway for future implementation. In this, the key performance indicators for this project, for technical stability and safety, the digester will maintain a pH range of 6.8 to 7.5, operate at mesophilic temperature of 35 to 38 degrees Celsius, and keep hydrogen sulfide levels below than 200 ppm. System uptime is targeted at more than 95%, with dashboard latency of less than 5 seconds, and contamination levels limited to less than 5%. For outcomes and decision support, the system aims to achieve more than 60% methane concentration, biogas yield of 0.35 to 0.5 per kilogram of volatile solids, and more than 50% waste diversion compared to baseline practice. Additionally, the greenhouse gas mitigation will be modeled and forecasting accuracy will be measured using mean epsilon percentage error less than 35% for last hour prediction. These key performance indicators ensure both operational reliability and environmental impact. So the project spans 48 weeks, covering design, fabrication, integration, field trials, and analysis. So phase 1 is from week 1 to week 20, and then for phase 2 from week 18 to the week 48. These considerations include safety protocol for biogas handling, process variability, and vendor abduction strategies. So for the significance and impact, this research carries significant practical and policy implications. First, it provides a Bazaar-Proximate waste-to-energy pathway tailored for urban Malaysia, addressing the surge in organic waste during Ramadan bazaars. Second, it reduces landfill burden and uncontrolled methane emissions, contributing to climate mitigation efforts. Third, the modular design, integrated information and SOPs, standard of procedures, create a reusable blueprint for decentralized waste management systems. Fourth, the project delivers empirical evidence specific to Ramadan operations, which can inform policy decisions and scaling the strategies. Finally, this work supports Sustainable Development Goal 12, promoting responsible consumption and production through circular recovery practice. In summary, Ramadan bazaars create predictable waste surge that current system fail to manage effectively. The project Modular Bazaar-Proximate Digestion offers an integrated solution combining modular anaerobic digestion, Internet of Things segregation, and forecasting model. This research will deliver a prototype and validate its performance during Ramadan, contributing empirical evidence for policy and scaling decisions. And the next step is to refine the site selection and stakeholder agreements before the phase 1 of methodology to be done. So these are a few references that contribute to my research, and there is a total of 24 references that can be related to this research that I use to find the research gaps. So here is the link for the complete 24 references. Thank you for your attention. I welcome your questions and feedback for my research proposal. Modular Bazaar-Proximate Anaerobic Digestion, Time Segregation, and Demand Forecasting. Thank you.